In this video, we are going to discuss this limit. We are going to use Epsilon-Delta definition to show this limit exists, right? We want to show that the limit of this function as x tends to 1 from left and right side, the functional value approaches 4. So let's consider any strip around this functional value. So this is the limit of that function at 1. So let's consider any strip around this value, around 4. So epsilon, take any take any arbitrary length of this strip around 4. Epsilon is any positive number. It could be very small or it could be very small. So let's consider any positive so length of this strip is 2 epsilon. Right, now let's consider this strip. So let's see whether we can find a delta. That delta depends on this epsilon, so such that all x between this interval, which interval, this is 1 minus delta, this is 1 plus delta, and these x values maps into these x values map into this area here. Let's see, we could find this delta. That delta depends on epsilon. So we consider the gap between the functional value and this epsilon here. So we measure the gap. So that gap definitely less than this gap here, epsilon, right? So let's take f of x, which is this value, take out take away 4. This is for the limit value. So let's so this is actually rough work. We have to so if you want to obtain a delta, let's see, we could find a delta so around this interval. Let's see, we can find a delta depending on epsilon, right? So this is actually rough work, right? So our function is 3x plus 1. Substitute that function 3x plus 1 and minus your limit. The limit is 4, and and this gap f of x, which is this, minus this value is less than epsilon. Less than epsilon. Let's simplify this one here. When you simplify the inside of this modulus one, right? So 3x plus 1 minus 4. So 1 minus 4 is 3 minus 3, right here. So 3x. So when you simplify this bit, you get minus 3 inside of the modulus less than epsilon. And here you can see that 3, the value of 3 is common of these two factors, right? You can take out 3 from the modulus sign, because 3 is a positive number. Modulus of 3 is again 3 itself, right? So so 3 times modulus of, what are the remaining terms? X minus 1. 3 times modulus of x minus 1, which is less than epsilon. So then you can rearrange this inequality. Here we have this one here. So you can take this term to the other side. You can bring this term to other side. So I divide both sides by 3. So then you don't get 3 factor 3 this side. So you get modulus of x minus 3 less than epsilon over 3. Okay, we have this form, right? So x x minus 1, modulus of x minus 1. So this one is centered around 1, So when you consider any value, yeah, so this means the length between x and 1, yeah, 1 is less than epsilon 3. So now I think you can choose delta. So this is a, yeah, so from here you can choose delta. If you choose delta less than epsilon over 3, right? So what happened? Yeah, so yeah, if you choose delta, so that delta is less than 3, then modulus of 1. Yeah, so let's consider this range. Yeah, so your delta is clearly depends on epsilon, right? So if you pick any value for epsilon, then that value, so then picking, yeah, choosing this delta depends on that epsilon value, right? So you have to choose a delta value, so that delta value less than epsilon over 3, right? So that implies, so this, yeah, this implies, yeah, this one and this one, yeah, this is true. If this is true, this one is true, and this one is true. Then finally, yeah, so this one also true. Then finally this one also true. Yeah, so therefore your functional value, the difference between functional and the limit value is less than epsilon, right? So this is the sketch work, right? This is the sketch work. Oh yeah, this is the rough work, right? You have to do this, yeah, you can do on a rough paper, right? So now how do you write this proof? So let's take for a given, like any, yeah, given any positive delta. So you could find, we have to choose, we choose a delta which is less than, yeah, so which is we could, sorry, right, so for a given del epsilon, we could choose a positive delta such that delta less than epsilon over 3, such that uh, yeah, so x minus delta. So if you pick, so we identified this delta, that delta depends on epsilon here. This is the, yeah, this is the dependency of epsilon, because this delta should be less than epsilon over 3, right? So right, so we pick a delta, right? So if you select any point in this interval, right? So this interval, yeah, in this interval, yeah, if you pick any x in that interval, so we are not interested in this point, right? We don't need to check that point, so we ignore that point. That's why I put greater than, yeah, so this is greater than 0. So that means we omit that point, right? We don't need to consider that point, but we have to consider other points in this interval, right? So if you pick any element in this interval, and that means x, so this is x, then x minus 1 is less than delta. This gap is delta, right? So yeah, x minus 1 is less than delta, right? Modulus mean you ignore the sign, right? So that implies that you can, yeah, that implies this maps, that point maps into this, yeah, strip here. So therefore we can say that this limit, so this limit of this function at this point x is. The value of that limit is 4.